the topic of my lecture is method of finding particular integral of linear differential equations. Linear differential equation particular integral is obtained when right hand side of a partial differential equation is containing, means here inverse operator, first we find inverse operator means 1 by f d, means q x is containing in the right hand side, multiplying f t and divide f t, means the inverse operator and particular integrals. F d is known as differential operator, f d is known as differential operator, and 1 by f d is known as inverse differential operator, means f d and 1 by f d q x is equal to q x. This shows that 1 by f d q x satisfy the equations f d y is equal to q x, and since 1 by f d q x does not contain any arbitrary constant, gives the particular integral f d y is equal to q x, means in case of a particular integral we have not mentioned the arbitrary constant, means particular integral does not contain any arbitrary constants. Hence, particular integral is equal to 1 by f d into q x. If f d is equal to, suppose f d is equal to d, suppose f d is equal to d, the particular integral is equal to 1 by d q x, means 1 by d is inverse of differential operator, means differential becomes integral, because integral and differential both are reciprocal to each other. 1 by f d q x is equal to integral of q dx. If f d is equal to d minus alpha, then the equation f d is equal to y is equal to q x becomes d minus alpha y is equal to q x, or dy. dy is nothing but y dash. Y dash means dy by dx minus alpha y is equal to q x is the first order linear differential equation, means how we find the value of y, means solution of this, means integrating factor. First we find integrating factor e is power minus alpha x, because alpha p is minus alpha x, means dy by, it is the first order linear differential equation, plus p y is equal to q. It is the first order linear differential equation. The solution of first order linear differential equation is obtained by y into e raised power p dx. It is, since we are required to find the particular integral, means it does not contain arbitrary constants, means we have q e raised power p dx and total dx, means here integrating factor is equal to e raised power p dx, means it is y e raised power p x is equal to q e raised power p x and dx. If here if p is equal to alpha, if p is equal to minus alpha, means if p is equal to minus alpha, then y e raised power minus alpha x is equal to q e raised power minus alpha x dx, means y is equal to e raised power alpha x into q e raised power minus alpha x dx. This but it does not contain the arbitrary constants. It does not particular integral does not contain arbitrary constant, means we have to omit C. Here it is the part of complementary function, it does not contain arbitrary constant C, and it is the we have already shown in the previous slide, e raised power minus e raised power alpha x integral e raised power minus alpha x q x dx is the particular integral, means it does not contain the arbitrary constant. Shortcut method of obtaining particular integral of q x is equal to e raised power a x plus b, f d y is equal to a x plus b. Consider f d e raised power a x plus b is equal to a d raised power n plus a 1 d raised power n minus 1 and so on a n e raised power a x plus b. Right hand side a 0 means d e replaced by a, the coefficient of x, a 0 a raised power n plus a 1 a raised power n minus 1 and so on a n e raised power x plus b, means f a. D is particular integral is obtained by putting a means coefficient of x in case of exponential in place of d, means it is the particular integral of e raised power, it is the particular integral of e raised power a x plus b. Also operating both side by 1 by f d, f d e raised power this operating both side by this, or it cancel out e raised power a x plus b, e raised power a x plus b is equal to f a 1 by f d e raised power a x plus b, or 1 by f a 1 by f a 1 by f a e raised power a x plus b 1 by f d e raised power a x plus b, when f a is not equal to 0. It is the particular integral of a x plus b, means the particular integral of a x plus b is equal to 1 by f a when a is obtained by replacing d, replacing a for d, means a x plus b, b is constant, f a is not equal to 0. If f a is equal to 0, f of a is equal to 0, then d minus a is a factor of f d, and hence the above rules fails. If denominator means 1 by f d becomes f a becomes 0, means we cannot find the particular integral, means this rule fails. In this case we take means f d minus a is the factor, let f d is equal to d minus a phi d, where phi a is not equal to 0, means particular integral is 1 by f d e raised power a x plus b is equal to 1 by d minus a phi d a x plus b. Replace here d is replaced by a, means phi a d minus a e raised power a x plus b, means 1 by phi a. The solution of this is we have already obtained in the previous slide, we have already shown in the previous slide, e raised power a x integral e raised power minus a x into e raised power a x plus b 1 by phi a e raised power a x e raised power a x into x e raised power b into a x 1 by phi a e raised power a x plus b, or 1 by f d e raised power a x plus b means x is equal to x into 1 by f dash a f dash a e raised power a x plus b, where f dash a is not equal to 0. Here suppose we want to find out the particular integral of the particular integral of 1 by f 1 by fd 1 by fd 1 by fd raised power n 1 by fd raised power n 1 by d minus alpha raised power n e raised power alpha x means it is nth order differential equation means 1 by means we have to differentiate multiplying x raised power n and differentiate n times we get factorial n e raised power alpha x. It will be the particular integral. If suppose it is n is equal to 2, we have 1 by d minus alpha raised power 2 e raised power alpha x means we have 1 by means x square by factorial 2 means 2 e raised power alpha x. If f dash a is equal to 0, then replacing the above process, repeating the above process 1 by f d e raised power a x plus b is equal to a x square into 1 by f double dash a x plus b when f double dash a is not equal to 0 means in general if d minus a raised power r is a factor of f d, then 1 by f d e raised power a x plus b is equal to, since it is rth order, we multiplying x raised power r and differentiate denominator r times means f dash a and replace d by a means this, where f dash r minus 1 is not equal to 0 means here if 1 by d minus, suppose d minus alpha it is cube e raised power alpha x means f d cube means factorial 3 e raised power alpha x when f double dash alpha is not equal to 0 means d we differentiate 3 times means second we differentiate 2 times we get d minus alpha, 3 times we get d minus alpha when f double dash is not equal to 0 means f double dash 3 times means third derivative is not equal to 0. Solve d raised power 4 minus d square minus 4y is equal to e raised power twice x plus e raised power minus 4x. Since it contains left hand side as well as right hand side, we find complementary function as well as particular integral, and the general solution is obtained by adding complementary function and particular integral. Auxiliary equation is obtained by f d is replaced by d is replaced by m means m square minus 4 is equal to 0. This implies m is equal to minus 2 and 2. Complementary function c1 e raised power minus twice x plus c2 e raised power twice x, particular integral 1 by f d into right hand side. The right hand side is e raised power twice x plus e raised power minus 4 x, means it is a combination of two functions, means 1 by d square minus 4 into e raised power twice x plus 1 by d square minus 4 e raised power minus 4 x. Here d is replaced by 2, d is replaced by 2, d is replaced by 2, means denominator vanishes, denominator vanishes, denominator vanishes in this in the first particular integral, and in the second integral denominator is denominator does not become 0 when we replace d by minus 4. Here denominator becomes 0, means we here 1 by d square minus 4 e raised power twice x. Here put d is equal to 2, d is replaced by 2, means we get 2 e square minus 4 e raised power twice x, means denominator vanishes, means we cannot find the solution, meaningless, means which is not solution, which is not a solution, not a solution. In this case we differentiate multiplying x and differentiate denominator with respect to d, and again d is replaced by 2, means we have x by 2 e raised power twice x. It will be the solution, means x by 2d into 2 means it is 4, x by 4 e raised power twice x, x raised power 4 x by 4 e raised power twice x, and it is minus 16 plus 16 minus 4, means it is 12 e raised power 4 x. Hence particular integral is x by 4 e raised power twice x plus 1 by 12 e raised power minus 4 x. Hence general solution is the combination of complementary function and particular integral, and y is equal to c1 e raised power minus twice x plus c2 e raised power twice x plus x by 4 e raised power twice x plus 1 by 12 e raised power minus 4 x. Solve d2y by dx square plus 3 dy by dx plus twice y is equal to e raised power twice x. It is the second order differential equation. Right hand side is not equal to 0, hence we find complementary function as well as particular integral. Particular integral means first we find auxiliary equation. Auxiliary equation is obtained by replacing m for d for m, means m square plus twice m plus 2 is equal to 0. Factor is m plus 1 and m plus 2 is equal to 0, means m is equal to minus 1 minus 2. Complementary function is equal to c1, m1 is here, says here m1 is mn is minus 1 and m2 is equal to minus 2, means complementary function is c1 e raised power minus m1 minus 1 minus 1 x means minus x plus c2 e raised power minus twice x, where m1 c1 e raised power m1 x plus c2 e raised power minus twice x. Particular integral 1 by fd into right hand side, means 1 by fd means d square plus 3d plus 2 e raised power twice x. Replace d bar for m, means d is replaced by 2, means 2 square plus 3 into 2 plus 2, means 4 plus 6 10 plus 2 12, 1 by 12 e raised power twice x. Hence, general solution is the particular integral as well as complementary function as well as particular integral means C 1 e raised power x plus C 2 e raised power minus 2 x into plus e raised power twice x by 12. It is the y is the solution means complementary function plus particular integral. Complementary function is C 1 e raised power minus x plus C 2 e raised power minus 2 x plus particular integral means e raised power twice x by 12. Solve d cube minus 5 d square plus 7 d minus 3 y e raised power twice x cos hyperbolic x. Auxiliary equation is m cube minus 5 m square plus 7 m minus 3 is equal to 0 means factorize it, we get m minus 1 square into m minus 3 is equal to 0 means m is equal to 1 means 1 is the quotient root of order 2 means twice, 1 is twice means complementary function is C 1 plus C 2 x e raised power x plus C 3 e raised power 3 x. Particular integral 1 by f d d cube minus 5 d square plus 7 d minus 3 e raised power into e raised power twice as cos hyperbolic. We write the formula for cos hyperbolic, we get e raised power x plus e raised power minus x, multiplying both we get e raised power 3 x plus e raised power x by 2 divided by 2 x, since if we put d for m denominator when says means multiplying x and differentiate denominator with respect to d means 3 d square plus 10 d minus 10 d plus 7, and in the second we again differentiate 2 times because it becomes 0 for 2 means we get the 2 differentiate 2 times. In case of second particular integral we get this, replace again d for 3 and in the second function d for 1 we get x by e raised power 3 x minus x e raised power x. Hence, complete solution is complementary function plus particular integral C 1 plus C 2 x e raised power x, C 3 in plus C 3 e raised power x plus x by 8 e raised power 3 x minus x e raised power x. Solve d square plus 6 d plus 9 y is equal to 5 raised power x plus log 2. Auxiliary equation is m is equal to minus 3, complementary function is C 1 plus C 2 x e raised power minus 3 x. Particular integral is 1 by d plus 3 whole square 5 raised power x minus log 2 means 5 x means 5 x 5 raised power x can be written e raised power x log 5 minus 1 by d log 2 e raised power 0 x, log 2 is constant and e raised power 0 x means 1. We put e raised power x, coefficient of x is log 5 means d is replaced by log 5 and here d is replaced by 0. We get the solution is 5 raised power x by log 5 plus 3 whole square minus log 9 this. Log 2 by 9 means hence the general solution is complementary function plus particular integral. How to find particular integral of sin ax and cos ax, differentiate 2 times we get d square is replaced by minus of a square, d square is replaced by minus of a square. d square is replaced by minus of a square, not minus, it is minus of a square, means in case of a sine and cosine we have to differentiate, d is replaced by, d square is replaced by minus of a square, not minus a whole square, d replaced by this, d is replaced by minus of a square. D square minus 9 auxiliary equation is m square minus 9 is equal to 0, means m is equal to plus minus 3 I. We have already obtained the complementary function of complex variable c 1 cos 3 x plus c 2 sin 3 x, particular integral 1 by f d. This d square is placed by minus 4, minus 4 means 16 minus this means minus 1 by 4. Hence, general solution is complementary function plus particular integral. Again sin square, right hand side solve, d square plus 1 is equal to sin square is complementary function is c 1 cos x plus c 2, because m is equal to plus minus I, sin square is 1 minus cos twice x by 2. We separate and write the right hand side 1 into 2 and we get the complementary function and particular integral. X raised power m, the right hand side x raised power n is obtained by replacing the denominator by partial fraction, not partial fraction, binomial theorem, binomial theorem up to reasonable and differentiate and get the result. Here d square x square plus 6 x square plus 18 x plus 12, again integrate 2 times, 1 by d square 2 times, we get this. Hence, general solution is c 1 plus c 2 x plus c 3 plus c 4 x e raised power x raised power 5 by 20 x raised power 4 by 12 2 plus 3 x square plus 12 x. Thanks.